Suppose we have two matrices, A and B. Compute and compare AB and BA. All right. So what are we going to need to do? Well, order for matrices matters. So let's work out AB first. So we'll put A in and then multiply it by B. 3171. 3, 2, negative 2, 4, I believe. Yes. Okay. So they're both 2 by 2 matrices. Eventually we'll learn to call these square matrices. We check the dimensions. The middle ones match up, and we're going to be left with a 2 by 2 matrix. Okay. So now we take the first row, 3, 1, dot it with the first column, 3, negative 2. So that's 9 minus 2, 7. First row, 3, 1, dotted with the second column, so 6 and 4, 10. Okay. We'll keep going. Now we're going to fill in the second row of our solution, which means we're going to take the second row of the first matrix and dot it with the columns of the second matrix. This is why order matters. The first matrix we use its rows, the second matrix we use its columns, which are very, very different numbers. Okay, 7 and 3 is 21, 1 and negative 2 is negative 2. So we get 19 here. Then 7 and 2, 14, 1 and 4, 18. So that's A times B. So now let's switch them around. They ask us to also do B times A. Okay. And if you've been paying attention, these should have nothing to do with each other. Yes, they're both 2 by 2 matrices, if you check. Okay. But that doesn't mean they'll be the same, and that doesn't mean they'll have any numbers in common at all. Okay. Let's see. 3 and 3 is 9, 2 and 2 is 13 in total. 3 and 1, 2 and 1, so that's going to be 3 plus 2, 5. See, very different numbers than the 7 and 10 we had above. A and B usually has nothing to do with B than A. Okay? A, B, and BA, very different matrices in general. All right, negative 2 and 3, that's negative 6. That's 4 and 2, so negative 6 plus 8 is positive 2. And then negative 2 times 1 plus 4, we're going to get another 2. Okay. So there we go. So they said compute and compare. Well, what I'm comparing here is AB and BA, very different, which is all we're trying to emphasize. Okay? Very different in general. You can find the rare situation where A times B and B times A are the same size and even the same matrix, but it is not something to suspect. Okay? It's not something that you should plan on or expect in any way. AB and BA, very different. Okay?